So guys, this is Ember, and it's a wildfire tracking in Indonesia. And at the bottom, we all did it. So all our names are there.
It accesses NASA's wildfire data and shows it in an easy way. It's using first responders and it translates hard-to-read CSV data into readable format there, which notifies your actions near you. It compresses it and provides software for some caching. It also merges the data from the two satellites. These are our whiteboards.
So we had a nice iterative design process and kept making our way back into the meeting room so that we could analyse the decisions that we made and review the scope of the project. Really have to make some quite difficult decisions on what features you choose in a project like this, but we chose the right one.
Inside it,
yeah, so the application works on using a hybrid model between a client and a server relationship. We've built an intermediary server which downloads the data from NASA and uses the processing power in the cloud in order to filter it down for the right geographical area, and then also make it queryable, which a large spreadsheet wouldn't be that easily. We then have a desktop client which can then fetch the data from our intermediary server, display it on a map, and display important information for first responders.
And that's the Windows Forms app and C#. It's just writing it. We did it on a VM. This is it in data mode, and it shows you wildfires nearby. And this is it in map mode. It's very basic. The next steps would be to add a red alert and a yellow alert system for different fires to cache a lot more, because as we discovered when the servers went down, that's occupied. We need to improve the geofencing to do more areas, and we need to improve the time zone support. And one of the slides seems to disappear. Just see if the data's working.
See the data we have still offline.
This is client data, and we made 55 commits. And this is the API, and this is what does the stuff in the cloud. We've also got, we might be able to show you just the data without, well, just the client without the data. Where's the mouse? Here we go, we won't get any data here because, oh, we did, it seems to come back online. Here's the data.
Ta-da!
Yeah.
How's that exciting? Yeah, we've had enormous fun playing with this. It's amazing how much data actually is available. The way it's presented to us is in terms of all of Southeast Asia, so it's really important to filter it down. We chose Indonesia as a country as it's a tropical country made up of hundreds of different islands. It makes responding to wildfires they're incredibly difficult, particularly if you've got areas separated by water.
And unlike California, there haven't been 300 people who have already done this.
But anyway, we've had enormous fun building this, and we'd love to continue working on it. Yeah. Thank you very much.
Thanks. Is there any questions for everyone to ask?
What kind of data you have? What are types?
We've got a CSV file which comes from NASA's Earth Data website. We've got two satellites. They're basically the same, and we've got latitude, longitude, brightness, track, inquiry time, inquiry date, how certain it is the issues of wildfire and a couple of other things.
These two satellites sit in polar orbit, so they're constantly scanning the area above. We get data updates approximately once every 2 hours, and we can use it to sort of make predictions based on visible light that's emitting from the surface as to whether or not this is likely to be a wildfire. The data that is included, provided very kindly by NASA, includes a confidence level, which shows how confident it is likely to be a wildfire, so we can use that to prioritise what we show and adjust the alert levels.
Was it possible to select other satellites? Maybe
There are only 2 available that do wildfire. I guess we might be able to get some general weather satellites and run machine learning to see if we could get predictions based on that, but we're just using the NASA ones for now because we didn't get all the features we'd like to as it is. It takes a long time to implement, so yeah.
So one of the challenges is Indonesia is a country which is spread horizontally on the equator.
Yeah, and it's also got a lot of islands, which means the geochasing, which brought it just down to Indonesia, is quite hard to work with.
So if you use the polar orbit, then it will come down vertically and you cannot cover lots of areas.
That's
So
correct.
lots of satellites Indonesia launches is on the equator, so they can cover more.
That's correct, yes. We are limited by that, however the data feeds have proven to be fairly steady and in terms of what is available. We've noticed by monitoring that there's certainly no shortage of information available that allows us to use these sorts of predictions.
We got scripts running in the days before it started, and it watched the 2 satellite feeds, and they update once every 2 hours.
So you can track the fire every 2 hours to see how it spreads. Is it?
Yeah.
Correct, yes.
You can keep that going right the way through for as many days as necessary.
Yeah,
Yes.
it just keeps on getting the data and showing.
Yeah, so it doesn't disappear. Are there any other places that you could track as a result?
Basically, yeah, we've got NASA provides segments for the whole globe, although we're only getting data for Southeast Asia right now.
Yeah. So you could ask for any other that you wanted. and
There's
track
certainly
that.
no reason why this functionality extended to any other country or region. We thought for the purposes of building a prototype, it's good to stick to one area.
No, that's fair enough.
With what certificate you can detect a fire?
The certainty levels are already predetermined by NASA, so we get there's a confidence variable that comes with every single record, so that ranges between 0 and 100. That we use that to determine the likelihood that it is a fire.
What would be the opportunity for sending that map or that data to somebody in the field to then say, I'm fire observation up 53, alerts just gone off 20 miles that way, and see.
The key advantage is that because Indonesia is a large area, the provincial fire teams are going to be spread out, particularly if you're dealing with tropical wildfires, then it's going to be difficult to get cellular access, and therefore having offline capabilities that can deliver geographic information is very important.
So would it run on a mobile phone?
It would be certainly adapted to run on a mobile phone. At the moment it's built to run on a Windows laptop.
A Windows phone?
The problem with using it on a mobile phone is because the capacity requirements of a phone are smaller, they often need more, you can store less information in them, whereas with a desktop application you can take it offline more easily.
Because it's pretty simple, it's probably compatible with one, and so you can use it on Linux.
Right.
Well done.